This is going to be a nice short video, guys. We've talked about parallelograms, and the shapes we're going to talk about today, it's really just looking deeper at those shapes. All right, so we're going to learn about a rhombus, a rectangle, and a square. All three of these are already parallelograms, meaning we already can establish opposite sides congruent, opposite sides parallel, opposite angles congruent, and that the diagonals will bisect each other. So we already know all that stuff is true because they already fit the template for parallelograms. A rhombus is a parallelogram, but all four of the sides are guaranteed to be the same. A rectangle is a parallelogram where all four angles are right angles, so it's 90 degrees at each vertex. A square sort of combines those two ideas and says, what if all four sides were the same? What if all four angles are the same? There are some corollaries that go along with this, right? So we're going to start getting into problems where I'm going to show you a shape and it'll have different markings on it and say, what's the most detailed thing you could say about this? Meaning any of these fall under the umbrella of their quadrilaterals. But when I see a quadrilateral is only a rhombus if we see these congruent sides. So if I see these congruent sides, I can go, you know what? I can be specific. It's not just a quadrilateral. It's not just a parallelogram. It's actually a rhombus. Right? So this is a great little visual. I'm sort of showing the overlaps. This is a great thing to pause and almost write in your notes yourself. All right. There's three separate theorems that we're going to learn about the diagonals. So we know already that the diagonals bisect each other. So like what we already know 100% is that on these, like this is going to happen. Right? We know the diagonals will bisect each other. What's interesting though is that with a rhombus, the diagonals are perpendicular. They're 90 degrees. Okay. We also see here a parallelogram is a rhombus if and only each of the diagonals bisects a pair of opposite angles. So on a rhombus, what else happens? The opposite angles, they're congruent and they're both being bisected. They're split in two. On a rectangle, the diagonals are literally the exact same as each other, right? I mean, we can figure that out by going that we know opposite sides are congruent. And because of the 90 degrees, opposite angles being congruent, we have side, angle, side. So we know that those two triangles are the same, which means that that line and that line have to be the same through CPCTC. And that's my quick little proof that diagonals are the same on rectangles. So for a square, obviously because a square is both a rectangle and a rhombus, a square has the case where the diagonals are the same and the diagonals are perpendicular. It fits both. Right? So we're going to start getting into homework. This is an interesting chapter. We've been doing so much calculating, and now we're getting into really stuff that's all about definitions. I'm going to ask you lots of true-false questions, ask you to sort things out. It's going to be a little bit different, but love it good. So I hope this video is helpful, and I'll check in again soon.